Hello everyone. So this class is concerned with DC motors and servos and seeing how they work and discovering how to code them. So I just run this here as a slideshow. So here we have a 180-degree servo motor, and it's essentially just a plastic case which contains gears, a printed board, amplifier, and there's a feedback potentiometer as well within this. So it's a potentiometer is just a variable resistor. We can change resistance by moving the potentiometer. So these have stop ends which prevent too much travel at the servo, so it can only rotate 180 degrees in either direction. That's the maximum we can do with that. At the base of the servo body are the wires. There's three which connect to the microprocessor or microbit board. There's an extra board that I'll show you now in a second. These are positive, negative, and signal. So we have 3 volts, which is usually the red there, the red wire that you see. The brown is the signal, that'll be varying in voltage. And then the earth then is the third wire. So what we do is, I can just save this one here, and I'll go into the microbit here. So what do we do then when we need to code this? So what we can do is go into inputs and have something happening on the pressing of button A. So something will happen when we press button A. What we do here is use the pins command, and we go in here to servo right pin P0 to something. So we'll start off at 0 with that. So when we do put this in, we automatically get a virtual servo here on the left hand side. That servo there can be controlled to 90 or 180 degrees depending on which way this is coded here. So at the minute at the press of button A, I just have it stationary. So what I can do is duplicate that, go in here, something happened on button B, duplicate, and something happened then on the press of A and B together. So we have 380 here. So we can change this here to 90. And this one here to 150, say. Lower now for a second. So what will happen here now is we have our signal wire coming from pin 0. The constant 3 volts supply is coming from that 3 volt pin, and ground is here. So those are the 3 I was talking about. So on the signal wire will allow this to vary the direction of this arm here. So it'll be around, it can actually move completely to the right here in center position or to the left. So I'll show you, just simulate this here now. So that's 90. And if we press A and B, it goes to 150. Now we didn't say 180. We could have said 180 here. I just put it to 150 just for simulation purposes. But it can go to 180, there's no problem there. And be at maximum then. As you see now in a second, when I press A, nothing happens. When I press B, it goes to 90. A and B, it goes to 180 to the full extent. When I press B, I can bring it anti-clockwise back round to 90 degrees. And I press A, I can turn anti-clockwise back round to 0 to start position. I've just thought something there. When it depends on which way this is wired, actually. When I pressed B there, it went to 90 degrees, and A and B, it went to 180. That's actually in a clockwise direction. We turn in a clockwise direction when we're going back to to the start position. We're going clockwise, so we're going anti-clockwise then 90 to 180. So that's the 180-degree servo motor in action there. So we'll go back to the presentation now. The 360-degree servo is something slightly different. With the 360-degree servo motor, it looks the exact same as the 180-degree. We need to we use it differently with code, or it's controlled completely differently to the 180-degree. So what we have here is pulse width modulation, PWM control, for controlling this particular servo motor. So unlike the 180-degree servo, varying the pulse between 1 milliseconds and 2 milliseconds varies the direction of rotation and rotation speed at which the servo travels. So in essence what we have is we still have the scale of 0 to 180, but this is the hardest part to understand. We actually map that onto the 360-degree servo. So we use a scale on the 360-degree. So it's a bit harder to understand this one, but we'll get there when we just stop and think. So I'll just go back to the microbit programming here for a second. I just want to show you something else that has to be done here now. We get rid of them. So in some situations, the motor can be higher voltage that's used in the workshop. Sometimes we can use motors that use more than 3 volts. So what we can do is here is go into extensions. I already have it done now, but you go into extensions in the microbit, all in one robotics. That connects robotic port, but I already have it in here, and it comes in then as robotics here. That's what happens. So when we're working this, then we can go into on button A pressed, duplicate that again, duplicate it again. So B, A and B. And what we're going to this time then is we're going to robotics here. We're going to servos. So then we say set servo 1. That's actually depending on, you can go from servo 1 to 8. So we say it's different servos on the board, on the robotics board. I'll show you that now in a second on the PowerPoint slides. So we'll duplicate this one here. Duplicate it again. So if we set servo 1 to 0 degrees, this time there's no simulation, but when we set servo 1 to 0 degrees, what we're doing is we're moving at full speed in the clockwise direction on a 360-degree servo. I just leave that thought for a second now. I'm just going to put in 90 here and 90 here. On button B, when we press button B, nothing actually happens. Servo stopped at that stage. It doesn't do anything if we hit button B in this particular situation. When we press button A and B, the servo will move anti-clockwise at full speed. So that's what will happen. If you download this code to the microbit, you can see this in action. I don't have a microbit here with me at the minute, but if you want to download this, like we did before, you go into download, X from that, go into this, I don't have it now because in my files, because it's just called microbit in the files, and you drag this folder, this into the folders, into the microbit folder, and then that downloads to the actual, the physical microbit itself. So what we need to do now next is just go back to the PowerPoint slide here, and that those actions that we're talking about for when we press the 90 or button B 90 degrees, it's just stopped. The servo doesn't do anything. As I said before, when we press button A, the servo will move in the clockwise direction at full speed. If we put some other value into the microbit program here, if we put say 30 into that, and we put 150 in here, and then in that case is the motor will turn anti-clockwise at medium speed when we press button A and B together. When we press only button B, the microbit will or the motor will turn clockwise at a medium speed. So it'll turn clockwise at a medium speed here, and at this one it'll turn anti-clockwise at a medium speed when this line of code is run, when we download it and run it. If you have your own microbit at this stage, maybe you should pause this video and try and do that, because it was beneficial to actually see how this works. When we get back into the class, we'll be going through this in fine detail anyway, to see, because this will be part of the Jitterbug project. So that's that part now. I'll just go back to the PowerPoint again. There's an application of servos here. So it's a wheelchair accessible car. That's a link to the video. You can check it out there. It just shows the application of servo motors to do lift the doors and control the wheelchair, accessible ramp, and that for the person. This board here is used to control servo motors and DC motors. So there's 3 wires that we saw up here on this 180 degree servo, 3 pins here. Those 3 pins click onto SV1 here, and that's servo 1. When I mentioned earlier on servo 1 to servo 8, I was referring to these pins. So next we're looking at DC motors. So the microbit has the ability to power electronic components up to 3.3 volts. So that's the maximum it can output on pin 0 or pin 1 or 2, the output pins. Simple solar style motors that have no load can be driven directly from the microbit board. So that's up to 3.3 volts. That's the maximum we can take. If we have any more than a 3.3 volt motor, a strong motor, we use this breakout board and we can connect the power supply in here, plus and minus 9 volt or 12 volts, or of course there is a maximum on that that we can connect into these 2 pins. So that will power then a stronger motor. So we can go in and code this next. This is slightly different again to what we're used to with the servo motors. So the first thing we need to do with the DC motors is go into inputs here. Sorry, go into basic. And on start, we go into robotics then, motors. Sorry, just into robotics itself there, and turn off all outputs. So the first thing we have to do with the DC motor is turn off all outputs, because the microbit has to know, it has to get an off signal first before thinks about turning on. Just with a DC motor, it has to see 0 first before it starts doing anything. So then next we can say button A pressed. motors again. So motor 1 on direction forward, speed 0. That it won't start at that, so we have to put in some speed here. Put in 100 there, that's full speed. So we can duplicate that again then. B here, and go into reverse. And then we go into speed 50 there. And duplicate. C. Sorry, A and B, motor 1, direction forward 0. So what'll happen there in that sense what'll happen there is that the motor will start, it'll go in the forward direction at a speed of 100, or full speed. That's maximum speed, can't go any faster. On button B pressed, the motor will turn in the reverse direction at half speed. So 50 is half speed. That's how that works. Then if you press A and B, the motor will stop. That's what happens there. It'll just stop completely. Nothing will happen. It'll go from a state of movement to stopped. So that's our DC motor there. When we're using the breakout board with the DC motor, we plug in our microbit here into this slot, and we use motor 1 here. We can run a couple of motors. In our case with the Jitterbug project, we'll be just using one motor, so we connect it in here in a particular way so that something called the polarity is right, that we have the motor turn in the right direction. It can go either way. The wires from the motor can go in either direction here, but we need to stick to one particular way with everyone to ensure that the motor turns the right direction. So that's it. Thanks a lot, and I'll chat to you again.